Today's lesson, difference between cis isomer and trans isomer. Let's take a compound as example, that is butene dioic acid. Butene dioic acid. Its molecular formula is hydrogen, oxygen, oxygen, carbon, carbon, hydrogen, double bond, carbon, hydrogen, carbon, oxygen, oxygen, hydrogen. This is butene dioic acid. Let's write its cis and trans isomers. Carbon-carbon double bond. Here carboxyl group, here hydrogen. In this carbon, this is carboxyl group, here hydrogen. Similar groups or large size groups remain on the same side of carbon-carbon double bond. That is why this is cis butene dioic acid. Let's write the name of the compound. Cis butene dioic acid. Its another name is maleic acid. Let's write its trans isomer. Carbon-carbon double bond. Here carboxyl group. Here hydrogen. When these two groups are interchanged their places, then we get trans isomer. Here hydrogen, here carboxyl group. Large groups or similar groups lie on the opposite side of the carbon-carbon double bond. That is why it is trans isomer, and its name is trans butene dioic acid. Its another name is fumaric acid. Now let's see what are the differences between them. That is, differences between cis isomer and trans isomer. Here we see that in this cis isomer, large groups are on the same side. That is why this is not a balanced molecule. This is not a symmetrical molecule. This is unsymmetrical, imbalanced molecule. But in this case, two large groups or similar groups remain on the opposite side of the carbon-carbon double bond. That is why this molecule is a kind of balanced molecule, symmetrical molecule. That is why first difference is cis isomer is less stable and trans isomer is more stable. Number two, as molecules of maleic acid are imbalanced, not symmetrical, that is why molecules remain far apart in this substance. That is why its melting point is lower. But in this case, molecules are balanced, symmetrical molecules. That is why molecules remain close together. That is why its melting point is higher. For example, less melting point. Its melting point is 135 degrees Celsius. But in case of fumaric acid or trans butene dioic acid, more melting point, and its melting point is 2 287 degrees Celsius. Third difference is cis isomer can form anhydride, but trans isomer cannot form anhydride. Let's see how cis isomer can form anhydride. Anhydride formation by cis isomer. This is cis-butene-dioic acid or maleic acid. When this compound is heated at the temperature 165 degrees Celsius, then one molecule of water is removed, and as a result, maleic anhydride is formed. This is maleic anhydride, and water is formed as byproduct, maleic anhydride. Anhydride is defined as a compound obtained by removing water from a particular carboxylic acid. This is called anhydride. But in case of fumaric acid or trans-butene-dioic acid, carboxyl groups remain on the opposite side of the double bond. That is why from this compound water molecule cannot be removed. That is why from trans-butene-dioic acid anhydride cannot be formed, but from cis-butene-dioic acid anhydride can be formed. Let's proceed. Let's see about net dipole moment. The compound is 1,2-dichloroethane. This is 1,2-dichloroethane. Let's write cis and trans isomers of this compound. Carbon-carbon double bond, chlorine, hydrogen, chlorine, hydrogen. Similar groups remain on the same side of the carbon-carbon double bond. That is why this is cis 1,2-dichloroethane. Let's write trans 1,2-dichloroethane. Trans 1,2-dichloroethane. In cis isomer, this bond becomes polar and this bond becomes polar, and ultimately this compound has a dipole moment, and its dipole moment is 1.3 dBi. That is, it has dipole moment, but in this molecule dipole moment of this bond cancels dipole moment of this bond. That is why dipole moment of trans molecule is 0. So dipole moment of cis molecule is positive, but dipole moment of trans molecule becomes 0. This is all about difference between cis and trans isomers. No more today. Thank you very much.